Okay, nerds, let's get started. Alright, these are going into our notebook. We're going to do notes on ionic compounds. Okay? Pause when you need to, and fill in, use a few colors. Alright, so we already know ionic compounds are when cations, when positives are attracted to our anions, are negatives. Okay? Cations become positive by losing electrons, and our anions become negative by gaining electrons. Okay? So we're going to do a few examples, and then we're also going to do some naming as well. Okay, so first example, let's do lithium oxide. Okay, so first thing we have to do is we have to be able to figure out our charges. So lithium, our cation is always listed first. Okay, and we'll just underline that in red. You can only have two parts to any single name. So we have lithium. Oxide is going to be our anion, our negatively charged part. Okay. First thing we're always going to do is look up your number of valence electrons. So lithium is in our first column, so we have a charge of positive 1. On the back as well, we're going to have listed up here are all our monoatomics, and down here are all our polyatomics. Polyatomics are made up of more than one atom. Okay, so like perchlorate is chlorine with 4 oxygens, has a charge of -1. Okay, take a look here. The biggest part of this is practicing finding all of this. Okay, so if you're not using this, you are going to run out of time on your quizzes. It's practice, practice, practice. Okay, so like carbonate, CO3, its charge is -2. All right, so lithium we just said has a charge of +1. I'm going to give it 1 valence electron. Oxide. Okay. All monoatomics, we're not going to call it oxide anymore. Okay, or we're not calling it oxygen, we're calling it oxide. So we're looking at oxygen. If you flip to the back, here's our oxide. O with a charge of -2. Okay. So we have oxygen. Oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. Now the idea here is we have to transfer our electrons. Okay, so if lithium transfers R1, it's complete, but oxygen only has 7, meaning we need another lithium. Okay, so lithium always has 1 valence electrons, and both of these would be transferred over to oxygen, giving it a complete shell. Okay, when we write our formula, we write this as we have 2 lithiums, Li 2 down here, this is our coefficient, and we have 1 oxygen. That's our ratio. Okay. The other way we do this is called crisscross. Okay. So what we simply do is we look up our charges. Lithium has a charge of +1. Oxygen has a charge of -2. Okay. These two numbers, unless they're equal, get switched. So this 2 goes down here for lithium, and our 1 goes behind the oxygen. Same thing, we have a 1 to 2 ratio. And the whole idea here is we want to fill up our shells. Everyone wants a full, stable shell. All right, so let's try doing just our crisscross method with some other examples. So let's do sodium sulfate. Okay, so that is sodium sulfate. All right. So, biggest thing, like I said, is practicing finding all these. Sodium we know is going to be our cation, so it's going to be one of our metals, which we know is on this side. Sodium, Na, first column, charge of +1. Double check, we are correct. Now, sulfate, we're ending in 8, so it's not sulfide. All monoatomics end in "ide," so we know it's a polyatomic. So right now we're looking down here for sulfate. Find sulfate. And what's our chemical formula? There we go. SO4 with a charge of -2. This is 1 sulfur and 4 oxygens. All right, so sodium Na, our charge is +1. Sulfate, our charge is -2. SO4. Because our charges do not match, Okay, that means we're going to need 2 sodiums for every 1 sulfate. So if we were writing this formula, this would be NaSO4. So right now we have 3 elements: sodium, sulfur, oxygen. We have 1 sodium, 1 sulfur, 4 oxygens. So there are 6 atoms altogether made up of 3 elements. This is one compound because we're made up of multiple elements. Okay? Let's do another one. Let's try aluminum sulfide. Alright, aluminum sulfide. Go ahead, find aluminum, look up its charge. Find sulfide, and find its charge. Once again, "-ide" means it's a monoatomic. Alright, so if we're looking up our charges, on the back, we're looking for aluminum, which is here. We know that we have a +3 charge. Sulfide's over here, we have a -2 charge. Since our parts don't match, we are going to crisscross. We will need 2 aluminums, and we will need 3 sulfurs. This is our chemical formula for aluminum sulfide. Okay, we have 5 atoms altogether. We're made up of 2 elements. This is still one compound. Okay. Some metals, especially a lot are in our middle, like iron, can have more than 1 charge. So if you're writing its name out, we would have to have that 2 or 3 in there. Okay? So let's just say we're doing iron 2, let's say phosphate. Alright, so this, our Roman numeral, will always tell you the charge. So aluminum has a charge of +2. Phosphate, go ahead, find that on your periodic table. Phosphate has a charge of -3. Okay, same thing, these don't match up. So formula would be Fe3. Phosphate is a PO4. Okay, and we want 2 phosphates. Okay, in doing so, I can't put a 2 here because that would be 42 oxygens. So I want 2 phosphates. This is when we use parentheses. PO4, 2. Okay, to break this down, this would be 3 irons. And now we multiply these out. Okay, so a PO4 is 1 phosphate with 4 oxygens around it. But I have 2 of these. Okay, so I have another one. So right here, for our phosphorus, there are 2 of those. 1, 2. For our oxygens, there are 2 groups of 4. 4 times 2 is 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have phosphorus, there are 2, and 8 oxygens. Okay, this is our polyatomic, this is a monatomic, and together this is still one compound. Okay, let's do one more. Go ahead, let's do let's do actually one where the charges match. So let's say we're doing calcium oxide. Alright, so for calcium oxide, go ahead and look up your charge of your cation and your anion. Calcium has a charge of +2. Oxide has a charge of -2. We are doing crisscross, but we don't need 2 of each. We can always reduce this. We actually only need 1 of each. And this goes right back to our number of valence electrons. If we're looking at calcium, we have 2 valence electrons. 1, 2. If we're looking at oxygen, we said it has -2 charge because it's in the 16th column. Oxygen's here. 16th column means we have 6 valence electrons. So we have oxygen with its 6. 1, 2, 3, 4, 5, 6. It will want to pick up 2 more, giving it a charge of -2, but this is why we only need a 1-to-1 ratio. Okay? These 2 electrons will go right over here to fill our last 2 spots. 1-to-1. So anytime our charges, if you have a +3 and a -3, if they're equal out, you only need 1 of each. Our formula for calcium oxide is just CaO. Okay? And that is how we do formulas. Any questions? Come on up and ask.